Hi, I'm Deneen Matsuda, and I have wonderful Stanley with me here today. And it is summer vacation. I'm gardening, dancing, cleaning my house, and doing what my good friend Shirley White calls recovery. Summer vacation is really a recovery period. We want to share something with you that we worked on 2 years ago that you might find useful, something that you might have some time this summer to give some thought to as you make plans for the new year.
So 2 years ago, we did a breakout session at the North American Division Educators Conference in Phoenix, Arizona.
Mm-hmm.
So that was in
It was hot.
2023. And I actually found the video on the Adventist Education Journey to Excellence website, and I downloaded it. And it's on our YouTube channel for you to watch. It's over an hour long, so in the description, I put in a table of contents with bookmarks to each of the different sections that we spoke on. And the topic was?
Lies that we teach in mathematics.
Actually,
What?
it's lies we teach in math class.
He's very precise.
Yes, so anyways.
We had a really, we're really thankful for the opportunity that we had to get to learn with so many teachers from all over the United States and Canada. And so I'm going to share with you what the lies are that we addressed, and then you can look for them if they are something that you will find interesting. So these are some of the lies that we addressed. One, you've heard this before. Lie number one, people are either math people or not math people. We know that is no longer true. It never was true. Now we know it's not true.
Okay, hold on. Actually, we had to skip line number 1 and line number 2. So that's really line number 3 on the video.
Okay.
So if you're searching for line number 1, we skipped over that. And line number 2, we skipped over that just because of time.
Teaching the way we were taught is best. And I think this is prevalent with so many teachers, probably worldwide.
And this is line number 4.
We were taught a certain way, so clearly this is the best way for us to continue teaching. And I kind of have thrown most everything out of how I was taught. And I'm always trying to learn better ways to meet the needs of our students who have ever increasing needs, ADHD, other needs. It's just, I can't teach the way I was taught, or even, I can't even teach the way I taught in the beginning of my career. When I think about that, it's so completely different.
Line number 5.
Time tests are a good measure of math fluency and knowledge. Don't know who started this lie, but it is prevalent and our students believe it. If you'd like to have a heart-to-heart with your students about their opinions and feelings of time tests and what it does to their self-worth, it's a really humbling experience. It's a great first week of school, heart-to-heart with your students.
Line number 6.
Speed is important for math success. Here's another one that I spend the first month of school trying to break this lie apart and the rest of the year. This one is deeply ingrained into them, and it's something that you might find interesting to address with your students next year.
And line number 7.
Algorithms are the best strategy for attacking problems. I used to believe that. I don't any longer. I'll never forget the day Ella told me this year, I don't even remember how to do the standard algorithms anymore. And, I guess to some math teachers that would be horrifying, but I loved it. I loved it so much I wrote it down so I'll never forget it. There are so many other strategies that are so much richer than just the standard algorithms.
And line number 8.
Getting the right answers is math success. We spend a lot of time marking things wrong, and it has to be exactly right. And there are times when that is true, but when they're children, when they're learning, is that when it is true. Joe Bowler wrote a book, which we haven't even bought yet, but it's called Ish, where I think she addresses how an answer can be close and still have learning involved. Maybe I should read that this summer. But those are the lies that we addressed, and we hope that you'll find a couple of those of interesting topics for you, and we hope that you can spend some time, not all your time, because you have a lot of recovery to do. We want to thank you so much for being with us, for spending these years with us, these weeks with us. We love getting to learn together with you. Do you want to say anything else?
Nope. Have a great summer, and we'll see you next school year.
We'll see you next school year. Be safe. Okay, Stanley, let's begin. We're so glad you're here. Thank you.
Should we begin with prayer? Yes.
Okay.
Go ahead.
Dear Jesus, we just finished vacation. How is it that we're tired already? And none of us, I don't think, has their room ready. So we ask you to pour your blessing on us because we have your precious children to take care of. So bless our efforts, and thank you for this community that we are building together today. And all God's people said, Amen.
All right, so we're Stanley and Deneen Matsuda, and here's our contact information. You can email us if you have any questions after the session, or you can text us. If you call our cells and you're not in our contact, we won't answer.
He doesn't let me because he says it's spam. So.
Okay, so you can text, and then you just say who you are because you won't get the contact information. All right, so what we're going to do, and if you didn't go to the Cadence app to download our materials, for some reason, you're not allowed to upload PowerPoints to the Cadence app, so use a QR code to get access to my OneDrive and download it. And then the PDF is on the Cadence, but you can also go to Google Drive and download that. Okay, so on the desk or on the table in front of you is a Sharpie.
Share.
And as you walked in, you got one of these little tiny bags of tiles. So what you're going to do is take the tiles out, and you're going to write the number 0 on one of the tiles. And then you're going to put the number 1 on one of the tiles, and then number 2 on one of the tiles. Just like what's on the PowerPoint. Okay, so while you guys are writing down the numbers on the tiles, I'm going to explain to you, if you just Google math number tiles, you'll find a lot of websites that sell these things, but they're made out of plastic. So they kind of are light. They're light and they don't have substance to them, and that's why we like the ceramic tiles.
Does anybody need a Sharpie?
Now the ceramic tiles, what you have to
You need do you have tiles?
Tile store, and they sell it in a 12 by 12 sheet like this, and this has 144 tiles, so you get a set of 14. A set of 14 with 4 extra. All right. Other vendors will sell tiles like in a flexible, plasticky kind of material with felt. And then they're quieter instead of the ceramic, which is loud on the desk. But we like these because they're nice and thick and has substance. And then there's these tiles, which are twice as thick as ours.
Rachel found these at Home Depot a few years ago, and she just peeled and stuck them. They're marble. They look like something you could put in your bathroom. She guards them with her life. And then we just keep them in these little, we get them at Walmart, those little crayon boxes. And this is what my set looks like. It's not as pretty as Rachel's, but I keep coins in here and my tiles and toothpicks for my manipulatives. And I didn't bring a good example. I try to keep real money in here instead of fake money now. And the students really do value the money. They don't waste it or anything. Because I have learned that my students don't know their coins. You have 2 Post-its on your desk. I just want to play this now because I know I'll forget. One of them you'll use for an activity that we're doing on integers. But the extra one is if you would be willing to just leave a takeaway on the table, because some of us won't see each other again till heaven, right? So it would be really nice to just know what was helpful to you.
Okay, so what we're going to do, wait, do we do the activity first, right? Yeah.
Yes, okay.
Go ahead.
So in front of you, you have a piece of paper that has old 30-year-old construction paper. Do you see that paper? I always intended to laminate it, never got around to it, and look, you're doing fine. Carbon footprint and all. This is called Skillboards. And now that you have your tiles, you're going to need one Skillboard for 2 people. So you just need to put one, and you have to choose. I'll let you choose because each of you has one. But you're going to have to choose with your partner which Skillboard you're going to use. Okay, now, do you see 2 places on your Skillboard? Do you see 2 places on your Skillboard that has a 1 represented? Do you see that? There's a 1 represented. Yes. Okay, both of you take your 1 tile and place it on that 1. Okay, do you see on your Skillboard where there is a 2 represented? If you say yes, that would be really great. Do you see where there's a 2 represented? Okay, place it on the Skillboard. Okay, I'm going to do one more. Do you see on your Skillboard where there is a 3 represented? I feel really bad for you people in the back, like you are not going to get the full benefit. Hover over a teacher that's sitting so you can see what's happening. All right, teachers, are we okay? Can I have your eyes up front now? Can you give me a thumbs up if you see where this is going? There's going to be a place for every one of your digits, right? Thumbs up? Okay. So here's the thing. When I do this with my students at the beginning of the year, they think that's the whole activity. They go, oh, this is so fun. They think and they're 4th grade. 6th grade felt the same way. But, oh, no, we haven't even begun. Now, if you kind of look at your neighbors, you will see that there are probably 100 different Skillboards at different levels. We've got Roman numerals, we've got fingers, we've got operations. Can you kind of look at your neighbor and see the differences? Okay, so Marcy Cook is the maker of Skillboards, and she has 2 books, Skillboard 1 and Skillboard 2. And you can, what I'm going to do, I'm just going to show you an example of some of the clues she gives. Okay, so it starts with something like number of legs on a bird. So what level is that? Is that K1, maybe? Okay, then we go sum of 5 and 2. We're getting a little more advanced. 12 minus 4, we're getting a little more advanced. The remainder in 70 when divided by 8. What grade level is that? 2 more than the difference of 14 and 7. Less than 1 to the 8th power. High school, that's for you, Monterey Bay. Number of minutes in 1/10 of an hour. Square root of 64. Quotient of x divided by x. Do you see the range from K to as high as we go? Because I know secondary people, your students have gaps. Yes, they have gaps. And most of those people with gaps hate math already, right? So we need to help them fall in love with math. So what I'm going to do for you right now, I never recommend to you to do at home alone. I'm going to start with K on one assignment, and we're going to go all the way up, okay? So this represents all levels. Okay, you ready? Clear your boards. And know where your digits are. And this is not a race. If your partner can't find it, you're welcome to help them. This is not a win situation. Okay, here we go. Your first clue. The number of legs on a spider. And if you don't know, ask your neighbor. They will. I need to know that you found the two places where there is an 8 and you've put your 2 tiles because you're working with a buddy. This is a partner activity. And you will have students who will say this, can I do the whole thing by myself? And I say, absolutely, we're differentiating, right? Okay, here's the next clue. Stay with me. The number between 2 and 4. Okay, can we keep going? I'm going to do one more primary. Okay, don't be fooled by this clue. Teachers? The number of pedals on a tricycle. Okay, now we're going to move up the pace. Buckle up a little bit. The digit in the 10th place of 1,407. The digit in the 10th place of 1,407. And I do not show these clues. Why? I want them listening to my words. Okay, we're going to bump it up again. We're going to go to like e-ticket zone now. You ready? The smallest factor of 36. It's 1. Hey, I'm going to keep going. The number of nickels, and I let them have their manipulatives. These are like our daily life, right here. The number of nickels required for 45 cents. Okay, I'm not going to keep going because I think you get this. You get this, right? This is called Skillboard, and then there will always be one tile that is left over. How many of you think your students could benefit from Skillboards? Okay, Marcy Cook's website. And let me just warn you,
Oh, for the below board.
Marcy
Yeah,
Cook's
okay.
website, if I notice it's antiquated, it is. There's no search bar. So if you are having a hard time finding Marcy Cook, text me. I will help you. I will help you navigate her 1980 website. Okay, we're going to start today's class like an AA meeting.
No, actually, we're not going to start right away because I have to apologize that due to time, we have to skip line number 1, which is getting good grades in high school math is a good predictor of college success. And line number 2, which is early introduction to math concepts, will help students better understand them later. Now, if you really want to sit down with me and have a discussion, we'll do that right after the breakout is over. While we clean up, we can talk to you about this.
Or you can have lunch with us. All right, now AA. I'm going to say my name and my issue. And then you're very warmly going to say hi, Denise. Okay? Hi, my name is Denise, and I used to hate math.
Hi, Denise.
Now I know what that must feel like for those people who go up. Okay, now alcoholism is a whole other level. It is. But I see so many similarities between alcoholism and math anxiety. Just like years of sobriety can be washed away with one drink, you can spend days, weeks, months, and for those of you in multi-grade, years, helping your children get past math trauma from the past and math anxiety, and all it takes is one low score, one fail, one topic that they don't understand, but everybody else seems to. And they hit rock bottom. And what is rock bottom in math anxiety? I'm stupid. So I hope that you feel like this is a safe place already. I hope you feel at home. Because I'm going to ask you some personal questions now. Is there anyone here who feels like they're a math person? Raise your hand. Is there anyone here who feels like maybe, yeah, I really don't feel like I'm a math person? I'm so glad both groups are here. Is there anyone here who straight up has math anxiety? Okay, Liz, you, me, and Natalia. Okay, I'm really glad you're here. You know, my niece Jenny, we were talking about this, and she told us a story about how in Algebra 2 in Academy, she cried so many times that she got a piece of paper and started tallying every time she would cry. And she's a really bright girl, you know? And she said her paper would get crinkled up because someday she'd be so frustrated. She'd just crumple it up and throw it in the trash. And then she'd always go dig it out again. And it was tear-stained as well. And she just kept track of that all year long. Those of you who know someone who has math anxiety, I mean, we've seen little ones crying. We had a junior high boy sitting at our kitchen table, a big guy just heaving sobs. We've seen college students, we've seen high school students. Math anxiety is real. And if
I have a question. I don't know if I'm the only person who's experienced this, but why is it math anxiety? You don't see that.
because math has the power to crush human souls like no other subject. And this is what I tell my students.
How it all starts.
I will tell you that I tell my students, our Lord and Creator did not create math to make us feel dumb. But it starts very early, Jasmine. It starts in the beginning kindergarten when everybody or a bunch of people know the answer before I have even processed the question.
What happens?
That's when it starts. Reading is next. I would argue that reading is next, but math is a whole other bag of garbage. And who is the creator of deception? You're telling me he doesn't have his hand in math? You're telling me? Okay, my favorite math joke is, and on the 8th day, Satan created algebra. You're telling me that Satan is not working hard to make our children feel stupid in any way they can. He's there. But we have the Lord's army.
Amen.
Okay, let's stick with the script now.
It's just, okay, so here's the news. Those of you who feel like math people, you're right. You are math people. But from the work of neuroscientists and people like Joe Bowler, we now know that there's no such thing as a math person. There's no such thing as a math brain. With the exception of the severely disabled people, we all can learn math. We have seen Joe Bowler now twice at the National Council of Teachers of Mathematics, and she loves to show this picture of a nursery. Imagine a nursery with little isolates. This is a math brain. This is not a math brain. And she goes, this is not how it works. It's a deception. This is lie number 3, that there are math people. Aaron, you and I have had this discussion, and that there are not math people. It is a lie. But we have to teach this to our students, and we have to teach it to them well. If you are interested in looking up people like Carol Dweck on growth mindset, fixed mindset, if that's new to you, and Miles Kimball has a fantastic article about the myth of a bad math person. And I'll tell you what, this is the first thing I start with on day 1 of school, and the first thing I start with back to school night with my parents. I have to educate them, because we know that math is going to get hard. And they need to hear our voices in their heads, or better yet, their own voices. giving them encouragement for when math gets hard so that they know that that voice saying you're stupid is a voice that we don't want in our heads, and he has no place in our hearts.
So I apologize, I did not make a QR code for Jo Boaler. However, if you just Google her name, you'll come up with her Stanford University website, her personal website, UCubed website, Struggly website.
Have you all done any research with Peter Liddell's stuff? And
We're getting to Peter.
Yes, we're going to talk about him.
So I assign Jo Boaler videos to my parents on back to school night, and I make them send a paper telling me what they learned. She has short videos, 4-minute long. She has long videos. I sometimes go to sleep to Jo. She's British, so she could read from the phone book and I'd be happy. But my students love learning about Jo Boaler. We talk about her all the time, and they love knowing that they're math people too. So you want to know how to be a math person? The scaffolded math lady has my friend Angie, she has a sign on her door that says, want to be a math person? Be a person and do some math. And Stan, number 2, wore that shirt today for extra credit. We just met. Stand up and let us see your shirt.
There we go, Stan.
Now, do you know how your students see themselves as mathematicians? This is more important to me than anything that I could put in my RenWeb or whatever grading system you all use. So I on day 1, and I do it in the middle of the year, end of the year, and throughout the year. How is your heart? They're like, what? What do you mean? Yeah. What is your heart? How do you feel about math? You want to get some information. I don't give those placement tests. I don't give those. There are many ways to find out where your students are in math. But you want to know about your students. You give them a Post-it and you say, how do you feel when you fail a math test or a quiz? And it will make you cry how they feel. So that's why I wore this. We need to know how their hearts are in math. And if we don't love math, you know what I'm going to say. Yeah. Okay.
You should say it though.
We can't help them fall in love with math if we don't love math. We're not that good at thinking it. We are good at thinking it, but we need to love it too.
All right, line number 4, teaching the way we were taught is best. So when I was in high school, my math class followed this format. You come in, you take attendance, you go over homework, and then you learn new content. And what did learning new content mean? A straight lecture, right? It was just a lecture. When I became a teacher, I followed that format until I met Deneen, who has a totally different style. So she's all about hands-on math, hands-on activities, games. And so she kept talking to me about Marcy Cook and how her students loved math and enjoyed doing these things. And I said, you don't even know what you're talking about. You don't realize how many things I need to convey to the students, what my content load is. There is no time for me to be doing these little game things with my students. So then she said, well, Marcy Cook is coming and we can go and see. And I go, oh my word. Okay, so she convinced me. But in reality, I wanted to take a day off from work and spend it with my wife. So I sat through the workshop and then I said, oh my goodness, I actually see the value of this. And I think I could do this with my higher ed students. So I went to my local community college, and I taught at Crafton Hills College, and I did it with them. So while I was taking attendance, they sat down and did tiles while I was taking attendance, and then they just started to enjoy it. Then one day, you prep and you look at what needs to be covered, and I said, oh, there's just way too much stuff. I don't have time to do tiles. And so I walked into class and I said, there's just too much stuff we have to talk about today. I can't do tiles. And their eyes got big and their jaws dropped. And then one brave student raised her hand and said, Professor, did we do something wrong? So then we just did tiles the whole period.
I hear an amen. Is it possible for us to think of the textbook as one of many resources? Is it, I don't care what curriculum they give me. They could give me big ideas till the cows come home. It is one resource. Is it possible to teach concepts with games and hands-on activities? And even have days when we don't use the textbook at all? You may indeed have your textbook open while you're teaching your lesson and students are working on whiteboards, and we want them on whiteboards because they're more willing to take risks on whiteboards. Can some days look like this?
We think so. I just want to reiterate this point right here. How important line number 3 is, which is if you actually believe your students are math people, and if
they believe they are math people,
then, and if they're not understanding what you're trying to teach, right? So then you go to line number 4, which is teaching the way you taught. If you thought that that was best, and you're teaching that way, and your student is not learning the math lesson, then this is what my wife does. So it's so easy for me. This is how I prep my class. I look at the title, and I'm done. Okay? That's me. Okay? That is so easy. It's a 3-second prep. My wife spends hours because she says everybody can learn this. So I'm going to do hours of research trying to figure it out. And you have to be willing to do that, or else it's not going to work. Like, you're going to leave some kids behind, right?
it wasn't until I became a teacher that it dawned on me that my humongous weakness in math was my strength. Because I understood. It was never, why don't you get this, Wayne? I've taught you 5 times, why don't you get it? It was like, I get why he doesn't get it. Because I didn't get it. I still may not get it. And I feel really badly. We're running out of time. Our time is like almost up. I'm like in shock right now. I just want to cry. But
No, I heard this session is over at 1:30.
lunch goes till 2:30, Stanley told me. I'm just saying. So I want to say this in case I forget. I was just talking to my girlfriend Carrie this morning, and like I told her about a gap in some of my 4th graders, and she said, "Oh, that hurts my heart. It means I didn't teach them this concept." But that's not what it is all about. We know that about brain development. If the brain is not ready to receive it, it will not Velcro to the brain. It will bounce off as fast as can be. Any gardeners in here? We plant the seeds all at once. Do they ever come up at the same time? They'll even come up months later. So translate that into student years. It could be years. So please do not ever feel, I failed. I did not teach them what they needed to learn. Their little brains are going to get it when they get it.
And so, like, these concepts are abstract. And
Yes.
she's turning an abstract idea into something concrete. And that's so much easier for your student to understand. But it takes a lot of time and effort and energy to do that. So you just have to understand that it is going to be time consuming. But you don't have to go from 0 to 100%. She'll tell you, just start small. Just do one thing a time or one thing a year. And this is like, how many years of collection have you
I started
amassed?
teaching in 1986. And
So-
how I wish I could go back and redo those beginning years because I was not the teacher I was that I am today. Susan, amen.
Okay, so let's go to line number 5.
Those of you who are not teaching integers, would you consider this integer lesson the glow track of math? and share it with the teachers at your school, or maybe with your own children. Let's spread the word. Line number 5.
Time tests are a good measure of math fluency and knowledge.
I used to believe this. I've given hundreds, if not thousands, of time tests. Mad Minute, I bet you're with me. But we get very little information from time tests. We only see a recorded answer. We can't see the strategies. It doesn't mean they're not using the strategies, but I don't see them. They're a weak assessment tool, and it can be emotionally damaging. Now, what about those students who love it? You know, my son-in-law is like, I love those things. Give me one right now, I'll do it. Well, those students have already mastered the facts. They should be doing a different, entirely thinking activity anyway. So, yeah, we want them thinking. I'm going to have you think about little Rolando. He's a student. He is taking his multiplication time test. He doesn't know his sevens. So he does what any good student would do, skips around and does the ones he knows. And then at the end, the leftover time, he puts his hands under his desk and he figures out what the sevens are and writes them down. I now grade his assessment, and what do I think? He knows his sevens. I don't even have the opportunity to teach him his sevens because I think he already knows them. It's an illusion of mastery. And yes, using his fingers is a good strategy. It is. But there are so many more. And if he does not know flexibility, this is going to bite him you know where in higher math. If I can quote my good friend Will, who teaches secondary at my school, he goes, spouting off answers quickly is not necessarily going to serve them well. So, we want them to have fluency. We just change the way we're doing it. Not flashcards, not time tests. Jenny Babe Williams has helped me a lot in this area. She has a book full of math activities for all the 4 operations. Also, we have made a YouTube channel 3 years ago we started, and we have tons of fluency activities that you can send the links to your parents and have them do them at home with their children. You can do them with your students. I've even had teachers say that they have shown the videos in class, and they're well received. But I want to do just 2 with you right now. Okay, the boxcar one-eyed jack people, I don't know if any of you have ever heard of these people. They have tons of books for all the grades, and their website is totally hip and modern. So you can find them easily. But what you're going to want to buy their books. I'm saying this now because we're running out of time. And if you look at the cards, those little cards, those are box cards. I like them because they're small and there are no face values to them. Do you notice the jack is a 10, the queen is actually an 11, so there's no question as to what it is, and they're small. And I know that there are some of you who maybe teach in a community where these look too, sinful. So you can use Uno cards, you can make cards. It doesn't have to be these cards, but these cards are amazing. And I've been using these cards for 30 years, and I haven't replaced them yet. Okay, we're going to do 2 activities with you right now. The first one is bingo. And I'm going to have you stand up because this is reverse bingo. And those of you who are standing, you're already ahead. But stand up and take out your multiplication bingo card. Do you see it there? And you all have some little bean counters. Okay, this is called I Hope You Don't. And it's totally different from bingo. Bingo, I've noticed, becomes every man for himself. I won, I win. But you would be amazed at what happens with this bingo game. Okay, multiplication bingo, Wayne. Everyone needs to have their multiplication bingo card. And if you don't have, that's integers. It's right under your green. It's hiding right there. You do not want an integer card right now. That's it, Liz. No, it looks like this. Document cameras save lives. I'm so sorry we don't have one. This is what it looks like, sort of. Multiplication bingo. If you don't have one, please share. Okay, I'm going to say a product. And if you have any of the factors that go with that product, you get to sit down. I hope you don't have 36. So you're going, 6 times 6, 3 times 12, 4 times 9. If you have any of those factors, you sit down. Okay. And if you want to give those factors, you can. It was 36. It was 36. But, you know, as you go through the year, maybe you don't need to give the factors anymore. Okay, I hope you don't have 24. What? What are the factors of 24? Oh, 3 times 8. 4 times 6. No, what did I say? 24. 4 times 6. 2 times 12. Oh, Emily, I'm so sorry. It's okay. We'll play again. I hope. Look how few are standing. I hope you don't have 72. 9 times 8. Anybody? Oh, no one sat down that one. Oh, I'm alive. I'll do one more. I hope you don't have 10. 2 times 5. Oh, Brian. I hope you don't have 16. I hope you don't have 16. Okay. Then you get a lifesaver. The people who are. I'm not going to go all the way to the very end, but this is what I have found. The students hover around the people who are still up, and they're like, "You got this! Oh, you got this!" Instead of "Yes, bingo! I'm the winner," which is totally different. Okay, that's all for bingo. But look, you have integer bingo in front of you now. Do you see it has a bunch of integers? Did you know there's integer bingo? Do you know that this exists? And we don't have time to play, but let me show you the cues. You can vary them. It starts very easy. 49, that's one level of clues. The water level increases by 49 inches. Oh, that's positive 49. The absolute value of negative 49. You see, I can choose what level I want to do. It's differentiated. 99 plus negative 50. The distance between 50 and 1 on a number line, or 7 times 7. This is all in one game. So, high school, man, junior high, yes. And I checked on TPT before I came, and there are so many algebra bingo games. It's amazing. Okay, was anyone here 5 years ago in Chicago with us? Okay, so you know salute. So let's quickly teach our friends salute, because this one is incredible. Do you want to explain it, Stanley, or do you want me to?
You do the basic.
Okay, I'm going to do basic. Okay, so in salute, you're in groups of 3 people. You have 2 soldiers. Come, Annette, be with me. Okay.
Salutes play with the mini deck.
The mini decks
from
of cards.
Boxcars and
So
Night
give
Jack.
me. Okay, Annette. So Annette and I are the soldiers, and Liz is our general. So we each have a small set of cards face down. Okay, Liz is our general. She does not have to be the most fluent of the group, because she can use her tools, like her calculator or her multiplication chart. Everybody's learning in this game. And I'm going to, Liz, say salute to us.
Salute.
Okay, Annette and I are going to put our cards on our
I'm doing it.
Put the cards on the forehead and then look at our soldier, at our general. General, say, your product is...
Your product is...
What is the product? I can't tell you what it is. Can you see? I'll have to do it. Your product is 8. So right now, these 2 soldiers are going factors of 8. What are the factors of 8? What are the factors of 8? And they look at each other and they have to tell what they have.
Okay.
Right? Are you seeing how this works?
Okay.
And the first person who says the factor gets that card in a little pile. Okay? You can do this with addition too. It's so good. Okay, we don't have time, but you got to try. And you, when I say it's over, you got to give me your attention. So would you please play salute in a minute? Get with 3 people and play salute. You got to try it.
If you email us, I can send you everything.
1. Raise your hand if you can see an application for this in your classroom. Like the first day of school, right? Like part of your lesson plan is done. You're welcome. Stanley is going to show you how to do advanced salute. And Janelle, this is what I've noticed about games. I'm going to say this really fast. When do your students ever look at a worksheet and go, oh, can I make this harder? What else could I this problem. Never. But with games and activities, Janelle already did it. She did advanced salute on her own. But Stanley's going to show all of us how to be advanced.
Okay, so if you want to do advanced salute with addition, you just add another soldier into the picture. Okay, so you have 3 students, right? And then the general has to add the three numbers, and then one of the soldiers, like me, I have to add these 2, and then look at remember the total, subtract so I can get what's on my forehead. Okay? Another version of an advance would be, let's say all the negative numbers would be red, and then all the positive numbers are black. Okay? So then,
Best day ever. I love you all. We're taking you home with us.
right, and you can do multiplication with that one,
Or addition.
and addition.
Or
That's right.
subtraction. Yeah. Yeah.
No,
Okay.
remember subtraction is not possible.
Do you see how my brain works? I still struggle with integers, right? By my comment there.
You get 2 answers in subtraction.
Yeah.
So anyways, and if you can't think of a way to challenge your students by converting salute to something more advanced, don't worry, because your students will. Okay, they'll figure out something.
Janelle did it. Yeah, they're always, and they never change the game to make it simpler. They always, and they don't do that on worksheets. So my friend Will says this to me. He says, I don't care about their answers. I want to know how they got the answer.
That's right.
So, and he's secondary. Will is who I call when I get stuck in math. I hope all of you elementary people have a person that you call, okay? Because it's important for our students to see us struggle and that we need help and that we don't cry and say we're stupid. So when Stanley's in a meeting, I just call Will. And so he's, you all need that person. Okay, so I need to know what strategies my students have. Because is the 5th grade teacher and the 6th grade teacher, do they have time to do this? They've got a lot of content, right? So I feel like I'm kind of the last gap. Like I've got to fill those strategy holes if I can. So, so I call them up one at a time, and I have them turn over 2 cards, and I do this before PTC for addition. I need to know what addition strategies they have. So are they using, this is 7 plus 3, so are they using doubles plus 1? Are they using doubles? Are they using sums of 10? Are they using the 9 strategy? What are they doing? And they give me the answer, and I say, well, how did you get it? This year, out of my class of 22, I found 6 students who did not even know the 9s strategy at all. Is it because their 3rd grade teacher didn't teach it to them? Of course not. It's because their brains weren't ready when it was taught. So I say, how'd you get the answer? Well, I counted my fingers. And so I didn't see you counting your fingers. Well, they were behind my back. Oh, they learned the shame of hiding their fingers. And so I tell them, fingers are a great strategy. But would you like to learn another one? And they're like, yeah. So right then and there, I teach them that strategy. Then I do the same thing with multiplication. Later on in the year, I call them up one at a time. Say, how did you get it? What was your strategy? I want to know. And are they using counting by multiples? Are they doing halves and doubles? Do you know about that? You can do 25 times 12 in your head if you half and double it. Double it and half it. Double 25 to 50, half 12 to 6. That's exciting for them. Okay, but I know, I can hear you right now. That's lovely to me. But what do you do with the rest of the class while you're doing that? Okay. Right? Marcy Cook for the win. You have in front of you hard cards. Do you see them? Hold them up so I know they're hard. Okay. I never laminate these babies. They're ready to go. And she has these cards from K to algebra. And Tara and Carrie passed out a variety for you so that you can look at one that is comfortable for you. Like this is where my class would be. Some of the sets require 2 sets of tiles. Do you have any cards that have 20 squares? That requires 2 sets of tiles. It's called double work because you work with a partner. Do you see cards that have only 10 squares? That is for you to use 1 set of tiles, but it doesn't mean you're on your own. You can work with a partner. Erin and I can work together using 1 set of tiles. Now these do not become independent in the beginning. You have to, what do you do in those first days of school, Harry Wong? We teach procedures and what they do. So what are we going to do in math? I don't open my book. The students are probably saying, do we have a book? You know, we're doing all kinds of pencil-less math activities because I want them to fall in love with math. And so you teach them how to do this all year long from the beginning, and they will become independent on it. And she also has the answers here. And if I feel I need to, I'll just stick this on the wall, and it's the answers, and they go check. Students never, well, I'm going to cheat. Why? Because they're invested. They love it. They're like, I want to make sure I got this right. Now, if you come up with something like number of inches in a yard is 36, right? But what if I already used my 6 somewhere? That means I've made an error somewhere. So I've got to go back. And I also want to tell you this. There are some that you can't do right away. Like it will say a palindromic number. Well, I can't do that in the beginning. That's 11, 22, 33. So I have to wait until the end to see where that fits. Okay, and she has a way to track. Every set comes with a different tracking. So if I do card number 1, look at the top right. Way up at the top right. Do you see there's a number, or is it top left? Somewhere there's a number. Top right, top left, there's a number. That's card number 13. So then they track it off. Oh, I did number 13, so I'm done with that one unless I want to do it again. And would it be okay if they did it again? Yes. Let's do it again. Okay, so this other super, we don't have time to teach it, but I have to show it to you. These are called strata dice. Doesn't that look fun? And you only need a few sets, and then you can share with your neighbors and friends. This is how I teach place value. I don't have time to demonstrate this for you, but this is boxcar one-eyed jack strata dice place value, and she has it there. It's for decimals as well. And do you see what I did right here? Do you see I put a piece of yarn? Guess what? That's my decimal point. So we play together. Wayne and me are partners, and this is empty. The tray is empty, and I roll a 6. Where am I going to put the 6? And then Aaron rolls. He rolls a 3. Where's he going to put the 3? Okay, I just teach you this. After you've played one row, we see who has the bigger value. That person wins. And then it's like, oh, but what if you turn it upside down? Your partner can maybe get a bonus point, maybe. Yeah, and then you could also play fluency games with this too. And I have a video of, it's called Horse Race, if you're interested. Okay.
All right, line number 6. Speed is important for math success.
Albert Einstein, I think, says it best. He goes, it's not that I'm so smart, it's that I'm willing to spend more time than anybody else on this stuff. So, Jo Boaler, if you watch her videos, she says that mathematicians are some of the slowest thinkers. That's not what we learn in school. It's the first one's done who's the fastest. You're like, I gotta get this done. I gotta turn it in. I'm gonna go so fast, I'm not even gonna put my name on my paper. And I'm gonna turn it in, and then I'm gonna go to my teacher and go, teacher, I'm done, what's next? And so I teach my students, it's not the fastest turner-inners that I'm looking at. It's the ones who are the last. It's biblical. So, you know, right? So I want to show you a picture of Jet. His parents didn't name him for speed. They fell in love with the color, Jet black. And this kid was named, though, I mean, everything is a race. Like he trips as he's going out the class. I tell Jet, you just essentially left your patient open on the table and walked away. Like, everything's a rush. So all year long, I've been teaching my students, please, you know, go slowly. He he would make such silly mistakes on his assessments, and one day he was turning in his paper, in a hurry, and he had to pass by me, and something that day just clicked. And he goes, because doesn't he look frustrated? Wouldn't you look at that? You said, this child's in frustration mode. No. And so he goes, can I go sit over there and look at it again? I'm like, oh, yeah, okay. And so he goes over there, and then I see him going and get his pencil and getting his eraser and making some changes. And he turned it in, and he did so well. I can only pray that Jet takes this with him through life, because math success should never be associated with speed. And you can say that on the first day of school, and you know those kids are like those hurriers. So I have taken away actually all of my speed games. We don't play speed games anymore, except Salute. Something about the complexity of Salute, I'm okay with playing that one. But all my other snap games, out the door. I don't use those anymore. And let's see. Oh, I have this really good story to tell you about Pam Harris. She's a mathematician. And do you feel like the students of today don't know their multiplication tables and all the facts as quickly as we did? You can ask me 7 times 8 when I am, falling asleep. I'm going to know the answer. But my students are not as fast as me on that. So I found Pam Harris, was watching her, and she tells a story about her son. She asked him, he's in middle school, and she goes, do you know your times tables? And he goes, no. She goes, what? You don't know 7 times 8? And he goes, no. She was crestfallen. She's a consultant. Seth, she teaches everybody, and he doesn't know his times tables. And then he goes, and this is where I wish I had a document camera. So get me your paper and pencil. This is so cool. And he goes, but I can figure it out. So she expected him, I think, to use 7 and 8 as how he was going to figure that out. And this is what he said. I don't want to make a mistake, so I have it memorized, but I just want to look at this. He goes, I know what 100 times 36 is.
No, you need to say what the problem is first.
Oh. The Lord gave me stamina. He goes, if I need to find out, let's say I need to know what 24 times 36 is. She's like, what? You went from 7 times 8? So write this down, 24 times 36. He goes, I could figure that out. He goes, I know 100 times 36 is 3,600. You're doing this mentally, aren't you, with me? Half of that, do you see where this is going? Half of that is 50 times 36, which is 1,800. Half of that is 25 times 36, which is 900. And that's really close, because I'm trying to get 24 times 36. So 25 times 36 is super close to that. I'm seeing you nod, like you're like, oh, the angels are singing right now. And he goes, so I just need to take 36 away from 900, and 900 minus 30 is 870, and then 6 more is 864. So yeah, I can figure it out. The way we're teaching our students today may not give them that rote memorization of speed, but today, more than ever, we need students who can think. Amen? We want them to be able to take numbers apart, compose, decompose, do a variety of strategies. They need to have a variety of strategies to use in a variety of situations. And that will serve you all secondary and higher ed people so much more. Do you ever crave activities that take a long time? Like all we get are these little math problems about Descartes and Newton, right? And they're done in moments, right? And I was just wanting something that would take them a long time to wrestle with and ponder and argue and discourse about. And the Holy Spirit touched my friend Mark Smith. I don't know if he's here. He's from Portland Academy. And he randomly sent me a video of a man named Peter Liljedahl. He's a Swedish mathematician. And he has an hour-long video on YouTube for free. I was like, oh my goodness. He has on his website for free numeracy tasks. If you click on numeracy tasks, and he has them divided in primary, middle, and secondary. Now, high school, he only has 4 problems for you for free, but I'm wondering if he knows how much content you have to get through, or if maybe your problems take longer than ours. Our problems take a whole period to do. Sir?
Yeah, I just want to add an extra commercial for Peter. I met him 10 years ago when I started teaching math, and he completely revolutionized the way I taught math. If you ever have a chance to go see him, do it. It will
It changes
your world.
lives. This changes lives. He has 2 theories that I think I need to really share with you. One is that he says work needs to be done on whiteboards. Why? Because they're willing to take risks on a whiteboard. They're not willing to do that on a worksheet. And he says math needs to be done vertically. What? Like, I only have 1 whiteboard in my room. Well, the good Lord sent me the Gatlings, and they were trying to get rid of a bunch of whiteboards, and my vice principal said, hey, does anybody want some whiteboards? And I said, well, I don't want to be greedy, but I do want them all. So I have all these whiteboards in my room. They look hideous. They're just in the corner. But I don't care. I don't have a Pinterest room. Can you tell? I mean, I don't. And so the students are happy to pull them out, and we spread them all around, and we pray that the fire department does not come on that day, because it is leaned up against everything. And I do these problems for 2 days. Day 1 and day 2, I either modify it or I just change it sometimes for 2 days, because this is what I find. My developing students, their work looks developing. But day 2, their work looks like this. And I teach them, if your friends are looking at your work and copying what, we don't say, that's we're a family. We're helping each other. And if my friend can look and gain something, you've got to teach that, right? So I have to tell you this really funny story. I've done 2 problems. I've done a celebrity travel, do it. I think the secondary kids would love it too. And I've done earning screen time. And so in the celebrity travel one, you plan a day for a celebrity. So I said, okay, you have to choose a celebrity. I added that part. And so they went, they were choosing, they came back. Mrs. Matsuda, we can't choose. And I said, what do you mean you can't choose? They go, well, we've got it down to 2. And I said, well, who do you have? They go, Jack Black and Joe Bowler. And I'm like, Joe Bowler, the celebrity in the classroom. Yeah. I don't know how Peter earns his money, probably from the books he writes. But he gives you all these numeracy activities for free. I will try to do at least 1 a quarter this year. The students are talking. Oh, little Jackson, he's my little on the spectrum boy. He comes and he goes, this is advanced math. Like, they feel smart. And another one said, I feel really smart when I'm writing on this big whiteboard. You know, they're fantastic. And that reminds me, Boxcar and One-Eyed Jack people, while they have a lot of cool books, if you Google Boxcar One-Eyed Jack PDF, they have a ton of games for free. They have 2 through something and K through something. You can just download them. Boxcar One-Eyed Jack's free PDFs. If you don't have the money to buy the books yet, it's free. All right.
All right, so here we go with line number 7. Algorithms are the best strategy for attacking problems.
Okay, sometimes they are, but sometimes they're not. So can I tell you my first math lesson that we're going to start with? It's going to be teaching the concept that subtraction is distance. Subtraction is distance. If people are leaving and you want to come sit down, please do. So I wish I had my overhead. So just close your eyes and imagine 15 minus 8. Let's say I don't know 15 minus 8. But if I add 5 to 15, I get 20. And I add 5 to 8, what is that, 13. I bet I know 20 minus 13. So subtraction can be thought of as distance. And I'm going to hit that hard, day 1, which is exciting. But you know when it gets really exciting? Get your pencil in your hand. We've got 2 chairs right here. I would love to see them filled. Just sit. Seth, come sit down. Okay, write down 5,000. minus 439. Okay, who is in a hurry, excitement to do that problem? Like, bring me the Advil. I hate these problems. But if I have taught my students that subtraction is distance, what would happen if I take 1 away from the subtrahend and the minuend? Then it becomes 3,999 minus whatever I said. I already lost what I said.
No, you said 5,000, so it's 4,000.
I'm sorry. I need a document camera. But do you see how that works? You take away, okay, what did I say? 5,000 minus 539. 439. 5,000 minus 439. So I know that subtraction is distance. So if I take away 1 from the top and the bottom, then it becomes 4,999 minus 438. Do you see that the renaming is gone? That's the beginning of math in my class. And they learned, wow, this is going to be something. This is going to be something. You can send your students home with that on day 1, week 1, and they're like, what did you learn in school today? Something really cool. Algorithms are great, I guess, but do I want them to use an algorithm in that problem? You know, I hope that they would see another strategy, another way to do it, because that is increased thinking. Dr. Allison Mello, she goes as far as this. She says, the algorithm, ready, primary? The algorithm for addition and subtraction should not happen until the 3rd grade. Wow. Susan is saying amen. She suggests that we let them compose and decompose numbers with number lines and other strategies so that they understand it deeply, and then we swoop in with that algorithm. You know that song I taught you at the beginning? I used to think when I taught Malia that was like I should start with that. Now that's an algorithm, isn't it? Row, row your boat is an algorithm. I should not even teach that song until they understand with the counters and the strips. So delay those algorithms. Okay. But I do want to say, we assume that the textbooks are the best way to go because it's what's given to us. This textbook and a random box of manipulatives, and we think that's what we have to use. But I hope that you're starting to see perhaps an additional way. Okay, so Marilyn Burns. I've seen her twice now at NCTM, and she's amazing. We know that. She likes to give this word problem. There are 290 students, and they want to go on a field trip, so the teacher's planning for buses. 32 students can fit on a bus. How many buses will we need in all? And she showed us this student on a video, and the student, without thinking, grabbed her pen and started solving it because she had learned the algorithm in all. I used to have that poster on my room of keywords. When it's this, you subtract. When it's this, you multiply. When you hear these keywords, I don't do that anymore. Okay, so Stanley, take it away.
Well, aren't you? Oh, okay, so then the student added 290 plus 32 and got 322 buses or whatever. And so every child was on their own bus, and they had 32 extra buses who the drivers had a great time at the field trip. But anyways, okay, so this is a problem from where I work at the School of Pharmacy at Loma Linda. There's a course called Pharmacokinetics. And I'm talking to the high school teachers here because this formula is to find the clinically relevant steady state peak for a specific drug. So even though I gave you all the variables, the values of the variables, you could still solve it because you know the algorithm, but do you really know what that number means? Will your patients survive? No, right? Who knows? I don't even know what that means. I know what each one of those individual words mean, but I don't know what it means collectively. So we just need to work on being able to understand the why, okay?
Thinking, having them think is far more important than memorizing an algorithm. If you walk into my classroom now during math, it looks very different than when I was a beginning teacher. This is what math looked like when I was a beginning teacher. This is what math looks like now. You would think that I'm doing read aloud because the students are on the floor, they're at my feet, they're using whiteboards, and what I'm finding is that they like to call it experimenting. This is Matsuda, we're experimenting with our numbers. I'm doing my lesson with my book open, and they're on their whiteboards, and they start going, hey, does this work? Can I do this? And then they start creating their own problems and bringing them to me, and then I share them with the class, and then I can use those for my assessments, like the problems that they made. It looks very different in my room right now. On the last day of school, I told my students, I said, I used to be a textbook teacher, and I knew they'd be surprised, but I was not expecting them to, this collective gasp, but I said, I didn't used to teach this way. This is the way I teach now. And they love math. They love it. I wrote down some things that they said. Like, I asked them, what do you want me to teach? What do you want me to teach next year's students, And they said, teach us that the math books aren't everything. I lost my place. They said, teach our parents that mistakes are part of learning. Hannah came to me on the last month of school. She missed 3 on an assessment, and she said, do I have to take this home? And I said, that was a red flag. And her parents are not those kinds of parents. They're super chill. But that shame, I think, was put in us from the Garden of Eden, right? And then our parents put more shame. Like, parents will say, well, if you don't do this, I'm going to take away your privileges, right? So we've got to teach our parents. We've got to teach our parents. We've got to teach them all. Where are we, Stanley? It's my everything.
Didi, oh my word. Okay, talk about this.
Here, okay. Show me the picture. This is Jay. This is what he did in the middle of my math lesson. I said, what are you doing, Jay? He goes, oh, I'm taking notes.
Wow.
Right? He is a developing math student. You would think, oh, he's one of the fluent ones. He's a developing math student who loves math now and sees himself as a math student because we're doing it differently. Okay. All right. Are we ready for lie 8?
Right here. Oh,
Okay.
this one. You're doing this.
Oh, and there's a temptation when we're doing math games and activities to then go to our desks and do the stacks of work that we have to do. But I ask you to not do that. Play with them so that's where your information comes. Oh, and I can teach you the way to play games. You always stop when it's at the peak. Right when they're having the most fun, that's when it ends. Okay. So fractions, I could teach fractions all year long. I would love to teach fractions. Oh, I want to show you this on my document camera.
You're imagining
Give me one more, Erin. If we only show students from our textbooks, they're going to think that 1/3, which one is bigger, they're equal. Stanley can't understand this. He goes, that makes no sense. So yeah, it does. These are the same. 1 and 1, it looks the same. So we have to show them in a variety of ways. Stanley goes, well, that's 1 out of 3, that's 1 out of half. Obviously, which one is bigger? This one, it has more. But you've got to show them in a variety of ways. So one of my favorite ways to teach fractions, and this would be great for junior high, you have some dominoes at your desk, and So just experiment with that a little bit. Like I don't let them put up the same with the same, like a circle with a circle, unless we're at the very end of the game. And they have their calculators. And do you know these fractions? I have one for every single student in my class. I've had so many different fraction manipulatives, but I get these on Amazon. They're $10 a set. We don't do math without these. So when we're playing fraction dominoes, they have these on their desk and they're working with them. But I had no room to bring them all for you. I'm so sorry. But will you experiment with the dominoes a little bit? You know, you put like do you see a 1/4? Put it with a 25% or a 0.25. Do you see a 1/3? Put it with 0.333. And I have 2 algebra sets. There's one, you have an algebra set right there. If you want to look at the and Monterey Bay has the other algebra set right here. If you're secondary and you want to see it. The secondary, you know there are students who don't know this. So, do you see how, we don't have a document camera. You see how it goes? Like I have one here and then I match it here like this. Patty's nodding, and then you match it here like this. My little 4th graders know that 2/5 is 40%. What? How do they know that? Well, I have them have their calculators.
All right, let's move on to line number 8.
Let's move on. Last line.
Getting the right answer is math success.
In school, we put a lot of focus on rights and wrongs. For pity's sakes, we have a whole pen, right? It's like a color. But do we need to be so concerned about rights and wrongs in school all the time? Now more than ever, we need people who can think. Yes, there is a time you need to leave your hotel to get to your flight. But does it need to be all day long and in math? We need to teach our students that mistakes and failure and struggle are essential to learning. So I say it all day long, every day, and it's coming out of their mouths. Ellie, oh, I just made a mistake. My brain must really be firing. They'll say those things. I say, oh, look at the mistake you made there. Let's work with that. Oh, look how this mistake leads us to this solution. Oh, look at this struggle. You are struggling. You are doing hard things. This does not happen naturally. We must teach this, and it will serve them all their lives. Let me read to you what the current NCTM president just said about this in May. We must move past strictly defining mathematics as finding a correct answer. Let's instead teach every single one of our students how to make sense of mathematics so that they increase their opportunities for success. Marilyn Burns says it this way: partial understanding and confusion are a part of the learning process. So when they're confused, you let them know, you're learning. That's great, you're confused. Let's work on that. It's nothing for which shame should be a part of it, and that correct answers are only the beginning. How students reason is the goal. I'm not saying throw correctness out the door. You know, we need correctness, but does it have to be all the time? Every assessment needs to be rights and wrongs? Can we look at some assessments of how did they think on this? When a child rides a bike and falls, we don't go, well, clearly you're not a bicycle person. Maybe you're a tricycle person, but not bikes. We teach them to struggle, and we work through it. And we teach them that our brains grow more when we make mistakes than when we don't. And Stanley has a really funny story right now.
So when you were in school and you were doing your homework, your math homework, when you got the right answer, did you ever stop and ask yourself, why is that answer correct? No, we just went and go, yes, and then went to do the next problem, right? So there's really not that much thinking going on and analyzing why or checking why your answer is correct or thinking about why your answer is reasonable. So here's a problem from, again, from my work, the School of Pharmacy at Loma Linda University. And this is from my friend's class called Pharmacy Calculations. And he gave this problem on his exam. It says, if 3 tablets contain 975 milligrams of aspirin, how many tablets should contain 3,900 milligrams? Well, he received 2 answers. The first answer was 12 tablets. And the second answer that he received was 1,267,500 tablets. Now, which pharmacist would you like to have?
We have 2 more resources to show you that will be really useful for you right away. Math routines are a great place for that no right answer place. And I start every math lesson with 5 to 10 minutes of a routine. So we're going to teach you a couple of resources for routines now. How long do you do a routine? About 2 weeks or until it becomes routine. And I'll even go back and redo a routine because they need it or because they're begging to go back and do that routine. But it's a way to start math with thinking. This is not a right answer, it's not a wrong answer. This is a way for us to think. So do you know about subitizing? This is new to me. I just learned about it this year. You primary people know about subitizing, you know, with your 10 frames. But we upper grade people, we really don't know about subitizing, right? Never heard of it. Joe Bowler says this is a greater predictor of math success than anything else. So I'll explain this to you if you want. But subitizing, you get patterns. I got these on TPT, and you show one at a time on your document camera, and then you quickly, like a couple seconds, and then they write on their whiteboards how many it is. And then you have them tell you, have some share, well, how did you come up with that number? Our fingers can subitize, right? And they go more complex, and they'll say, well, I saw 3 here, and 3 here. I saw, you know, whatever it is they see, I saw 6 here plus 3. It's called subitizing. So that is a tremendous, tremendous routine that you can do with your students, and they love it. And we have a resource of a man who made subitizing for K-12.
So this is Steve Wyborny. This is his website. And then if you want, you could go to his YouTube channel where he explains how to use his materials. And Deneen will explain those 4 materials he has. It's just way too complicated. Like for me to verbally explain what it does, it's just a little too complicated. But if you can just imagine like a jar, and then it's filled with maybe marbles, and you have to estimate how many marbles there are in the jar, and then you guys work together and try to figure out, oh, there's maybe 50 marbles, and then he reveals the answer, and there's the same jar with a different number of marbles. So then you have to guess, did the marbles increase or decrease using the previous slide, and then you have
Prior
to
knowledge.
talk among your group and say, oh, well, it only got less by 1 row, and I think 1 row has this many marbles, so I think it's that. Then he reveals the answer, and there's another slide. So there's just like 4 slides of where things change. There's also like a string, and you have to measure how long is that string, and it's like all curved, and it gets shorter or longer, and it's just a way to just discuss, and then at the end you have a classroom discussion, and then you go on to your actual lesson.
So he has 4 games for routines. He has Estimation Clipboard, Splat, these are all on YouTube, Estimistry, and Cube Conversations, which are really for secondary. So that's Steve Wyborny. And then the other one that we need to teach you about is John Sangiovanni, and he has books on routines, and they're all by like middle school, primary, and high school. And Stanley is happy to show you secondary teachers a secondary routine right after, if you'd like to see. But here's just one. It's called Or You Could. Like write down 64 plus 48. We could add that using the standard algorithm. Or you could.
62 plus 50.
Whoa! How about 60 plus 40 and then add in the 12? I mean, do you see the rich or you coulds? Let's look at fractions. 2 3/4 plus 2 3/4. We could do the standard algorithm. Or you could take one of those fourths, move it over there, and you are seeing how it's going. And I have 4 4, so that's a whole. Do you see how this goes? But you have to teach this. The students won't learn this on their own. So, or you could is a really great, simple one that I can just show you quickly. People ask me, what does math look like? Rachel asked me that. Like, what does math look like? I start with a routine. Now, do I do a routine every day? Someday I may be too tired, right? Doesn't that happen? It's not in me. That's okay. But my goal is always to start with a routine every day, 5 to 10 minutes. And then I teach a lesson using their whiteboards, me at the book. And then I try to do a game or activity to support that. If there's time at the end, maybe we'll do some tiles. Some days, maybe we'll just do tiles, and we'll do a practice, a skill that we've already learned. Some days, we just do Peter Liljedahl. That's what math looks like. Okay, we're ready to close now, and we want to thank you for being with us today.
There's a tile.
In closing, we're going to ask you to do a couple things.
Every
for us.
tile has
During
to be
COVID,
used,
3
so
years
it's
ago, we
not
started a
collecting.
YouTube channel. And we've been at 250 subscribers for a really long time. So would you take out your phone and subscribe to me and Matsuda? And then maybe we can get to 300 subscribers. And then, if you could tell someone else, we can make our family even bigger, and then maybe we can get to 400.
We also made
Each Sunday, we post a video for you.
we also made a website called MatsudaMath.com, and my wife will explain why she didn't want to do that.
Yeah, I didn't understand. Why do we need a website? What are you talking about? I'm the most untech person in America. I don't even know how to do Facebook. But now I get it. I finally understand. It's because you can go and look, tools. What does Deneen use for tools? And it's right there. You know, it's really like a service for you. So we hope that will be, I have recommended tools, resources and games, because like you're going, where do I start, right? Where do I start?
And we also are on Facebook now, so we have a Facebook page called MatsudaMath. And then if you use social media, go ahead and hashtag MatsudaMath, and we'll see what happens.
I don't know if we have any people here from Wisconsin Academy. Not the conference.
Yep.
Okay, so Wisconsin has had us come twice. So, you know, the last time was on Zoom, which was really sad because of COVID, but we made the best of it that we could. Don't be afraid to start. You know, we teachers, we think, I've got to have my year-long plan, and I've got to have just start with something, one little thing. Don't be afraid to start. My friend, Superintendent Wayne Gungle, I just wanted to cry when he told me this. He's a superintendent, and he made little math, he's been watching our videos, and he made little math kits for his students. He made 15 of these. He's got the box cars, he's got dice, he's got counters, and when he goes into teachers' rooms, he's been playing games with them. And he was starting to get discouraged because he said the fire wasn't like spreading. And then one little guy recently said to him, "Hey, Mr. Gungle, why don't we do some more of those math games?" And that's all it took to, I'm doing what is good. I had the privilege of working with some students this summer, and on the last day, which was last week, they were like, you could see they didn't want it to end. I was taking them to ice cream, and they're like, And the little boy said to me these words, the 6th grade boy said, "Can we have 20 seconds of silence?" I said, "What?" He goes, "No, I'm serious. I'm going to put it on my phone." He goes, "Can we just think about what we have learned this summer for 20 seconds? He changed he changed me that day. So I know you want to go to lunch, but we're going to close our eyes. You can pray. You can think about what you've learned. You can think about the loved ones that you left at home. But let's have 20 seconds of silence, and then I'm going to pray with you, and then we'll say goodbye. Begin." All right, I'm going to close with you the way I close every day. It's called the mitzvah. We had to learn it on sign language because we all now know that you can't do anything in unison on Zoom. So let's do it together. Put your fists up. Yeah, you know how that went the first day we tried it. May the Lord watch between you and me while we are absent, one from another. Amen. My name is Janine. I used to hate math, but I don't anymore. Thank you. I'm Janine Matsuda. Thanks so much for watching, and don't forget
To like and